Okay, so we're about to look at routing policy in Chapter 3. But before we do that, I just want to talk about the takeaways from the previous screen and discussion. So there's several. The first takeaway from the discussion is this aggregate defaults brief. So set routing options aggregate defaults brief. As outlined, an aggregate route in its path is going to be showing all of the routes that contribute to it. So if you had a large aggregate like this 17230, then it could be taking on a number of routes. Now obviously this is an internal range, but on router 6 we're going to have an aggregate that's 0/0, and that is going to literally take on every route. So set routing options aggregate defaults brief is a very important command in this. The next thing that I just want to highlight again is this CBGP next hop self. So the CBGP and the IBGP, we really are treating all as IBGP because, of course, at the end of the day, it is becoming one IBGP cloud. Now, that means that on the next hop self, coming into, from an external route, coming into a router, we really do need to do next hop self both to IBGP and CBGP. But also we have to be careful that any routes coming in on CBGP doesn't get a next hop self to the IBGP, because it's considered the same cloud. So that's the next thing there. Okay, so let's have a quick look at this policy. So router 1 and router 2 are connected up to the Internet Exchange here. Now they're not using next hop self, and this is because they're sharing a multi-access network with the two routers at the Internet Exchange. And obviously the routes here are going to be sourced from that subnet. Now we're actually going to do that in MPLS. We're going to be adding that subnet directly into the MPLS on both LDP by using an egress policy, and also on RSVP by adding it to the ISP. And that's going to allow the resolution when we come into the MPLS. So these routes here really can stay from their source address or the next hop address of the IX1 and the IX2. And of course, the way we're doing that is passive interface on the ISIS. Okay, now let's have a little look at peer P1. Now, peer P1, clearly we want our customers to be able to get to it because the customers have ability to get to peer 1, but we don't want to advertise out the Internet Exchange. And I like to think of peer 1 as something like Amazon Web Services, some sort of external company that we've paid for lines to for our customers' benefit, but we don't want them advertised to the internet because we don't want that benefit being handed out to the internet. Otherwise, people that aren't our customers would come in through the Internet Exchange to get to peer 1. So that's how I'm sort of categorizing peer 1. It's a peer, but it's almost like a peer providing a service. Okay, and then peer 2 and peer 3. Now in this example we're not preventing them from exporting routes to each other, but in a later example we are. And of course peer 1 we're not having transit routes with v4. Okay, so what do we have here? Well, we have the policies requested on the right hand side, and then we have some terms that we're going to need in most of the routers on the left hand side. So let's have a little look. What we'll do, we'll go through the policies, what we need, and then without a shadow of a doubt it's going to be easier to go through each external peer and incorporate all of the policies that are required on that peer. Just makes it quite a lot simpler. So let's go through and see what we've got. So firstly, from customer 1, 2 and 3, the routes can go everywhere. However, the route to customer 2, it needs to be just a default. Clearly customer 2 doesn't require complex routes, default's fine. Okay, Internet Exchange and P1 are blocked to each other, and we're blocking IPv4 transit from P1. In other words, the origin must be P1 for the routes being sourced by P1. We've got a series of preferences here. The customer routes we want to be the highest preference. So if a route is originated in the customer, we want that to be the highest preference. We don't want to be going through the Internet Exchange to get to our own customers. We're going to use preference of 300. We would like P1 to be a higher preference than the Internet Exchange for obvious reasons. If P1 was, say, an Amazon-style company, we want to be able to get to it directly. We don't want to be going through the Internet Exchange. So we're going to be using preference of 200. R8 is going to be preferable to R7, so we'll go for 210. And then the Internet Exchange default preference of 100. And then the customers have the ability to lower the preference for certain routes. A little bit similar to black holing, but just a lowering of preference, and that can be done with preference 90. Okay, we've got a standard filter coming in from the EBGP. We don't want anything with an incredibly long mask or an incredibly short mask, so no supernets, no masks beyond 24 bits. However, on one particular autonomous system number, which is P3, we do want to allow a /32 if it's sourced inside P3, and that'll probably be used for some carrier of carriers at a later date. We want to block all default routes at all lengths. Okay, and then as we advertise our local route out to the internet and out to the various customers, we've got a couple of restrictions. We're going to be sending all our routes to everyone, like an aggregate, except of course for C2, that's just getting the default anyway. To P1, we want to do some load sharing. So to P1, we want to split our aggregate, our local aggregate in two halves, and we want to load share between 8 and 7. And then finally on these requirements, we've got sort of preferences in and preferences out. So for example, we want R8 to be preference, the preference exit point for P1, and we would like R6, not R7, to be both the inbound and the outbound to customer C1. Then finally, of course, we have the routing to black hole. And of course, as from this previous screen, we still have the log up and down that we want to be putting the state changes into syslog. We want to have various damping things on, and we would like to use standard communities. Now, that's a little bit interesting here. In order to use standard communities, when we come to define our community numbers that we're going to be needing in almost all of our routers, you'll notice that we're only using the second half of the 2 byte AS number, and that keeps it nice and short, keeps us in a standard community instead of in an extended community. Of course, we've given the customers the ability to lower the preference. So we're going to need to be able to recognize these customer 1, 2, and 3 low preference communities. And then the way that we're actually building this is we've got a default filter, which is literally just blocking the default route. So 00 through 032. So that's a default route. We're going to be rejecting it. So any length default route, regardless of mask. And we're going to have that default filter on the way in. And in this example, filter means inbound and a restriction, and export means outbound and a setting. Okay, so what we end up with, just generically, using just a group A, for example, set protocol BGP, group A, import default filter, then import A filter, export A export. So basically on the import, it's two parts, default filter and then the peer. Then on the export, we've got the peer. And then what we're going to do, we're going to go through these peers one by one, and we're going to incorporate all the policies.